Hello everyone, welcome to Partners DSA. So today we will be covering allocate minimum pages problem from Geeks for Geeks. So this is our given problem. Given an array of integers where each element represents the number of pages in the book. You have an integer k representing the number of students. The task is to allocate books to each student such that each student receive at least one book. So this is one of our constraints that we should consider while solving our problem. That I will quickly note down. Then each student is assigned a continuous sequence of books. Suppose we have an array 12, 34, 67 and 90. We cannot randomly take 12, 67, 90. We should follow a sequential order while taking the pages. Now no book is assigned to more than one student. So suppose for student 1 we are assigning the pages 12. Then for student 2 we cannot assign the same pages as it is already given to the student 1. So the objective is to minimize the maximum number of pages assigned to any student. In other words, out of all possible allocation, find the arrangement where the student who receives the most pages still has the smallest possible maximum. So now let us go through the example. So we have 12, 34, 67 and 90 pages and we need to split it between two students. So let's jump into the brute force approach. So here the objective is to minimize the maximum number of pages. So minimizing the maximum is about finding the best of the worst case scenarios. So in this if we are taking the example as this array 12, 34, 67 and 90. Suppose if we want to distribute this book to students, then at least our allocation should start from 90 pages. So that means that our allocation the minimum value of our allocation should always be the highest value in the array. So in our case, we will be having minimum value as 90 and the maximum possible pages that can be distributed will be the sum of this array. So if we are taking the sum, our maximum value will be max will be 12 plus 34 plus 67 plus 90, that is 203. So this will be our maximum value. Now our the least possible for minimizing the small. So in this case our minimum value will start from 90 and the maximum value will be 203, which is the sum of the array. So if we are trying to give the number 90 pages to a student, then the first book will get allocated to student 1. So for S1 for S1 first book will get allocated since it is less than 90, and if you try to allocate the second book, again it is possible to assign to student 1 since it is also less than 90, and if you try to assign 67, it will be greater than 90 and we won't be able to assign that to student 1. Now for we will be taking student 2, and if we try to assign 67, it is possible since it is less than 90, but if we try to assign 90, it will be greater than the number of pages that we have taken and we won't be able to assign that book over here. So we will need a third student in our case for allocating this last page of this array. So in that case we should increase our number of pages that we are taking. So I will be increasing it to 91. Then also we will face the same scenario. We can assign 12 and 34 to student 1 and 67 to student 2, and then we should take a third student for assigning this particular value. So this for splitting this between two students, if we are taking 113 pages only, we will be able to split it between two students. So if we are taking this array, we can take 12 we can split 12 pages to first student, then 34 pages to the first student. Then if we are taking 67, then it will be less than or equal to the number of pages that we have taken. So in that case this is we can assign 3 books to student 1 and our next element will be 90, which is less than the number of pages that we have taken, that is 113. So with 113 pages we can split it between two students and we can find the maximum possible, smallest possible maximum in our case. So this is the brute force approach. So in case of brute force approach, our time complexity will be big of array of size into the number of students. So it will be 10 raised to 8 more than 10 raised to 8 complexity, and it will reach TLE. So we should minimize the time that we will be able to find the solution. So if we look over here, our minimum and maximum range is in increasing order. So we can use binary search to find the solution for this problem. Now coming to the binary search solution, we will have our minimum value as 90 and the maximum value as 203. So our mid in this case will be 90 plus 203 by 2, which is 146. Now we will be taking the pages as 146 and we try to distribute between the students. So in our case, we can distribute 12 pages for student S1. We can assign 12 pages since it is less than 146. Then we can assign 34 pages more since the sum will be less than 146. And if we try to assign 67 also, it is also possible since the sum is less than 146. But if we try to add 90 to student 1, then it will be greater than 146 and we won't be able to allocate. So in our case, we will be assigning that to student 2, and student 2 can hold 90 pages. So we can see that this is a valid case, and all the pages which are greater than 146 can be easily assigned to 2 students. So we need to minimize the range in that case. So our maximum value should be less than 146 since all the combinations greater than 146 is available for distribution. So we will be setting our high as 145 and our minimum value will be 90. So our mid value will be 117, and again we try to distribute the pages. So for 117, if I try to distribute for student 1, we can see it can take 12, 34 and 67, and student 2 can take 90 pages in that case. Again our mid value so if we try to take 118, then also we can distribute it between 2 students. So again we need to reduce our range, and our highest possible value in that case will be 117 and our minimum value will be 90. So our min is 90 and our max will be 117. Our max will be 117 minus 1, that is 116. Now again we need to find the mid, and our mid will be 103. So in this case, if we try to split 103 pages between 2 students for S1, if we give 12 pages, we can give 12 pages to that student, and if we give 34 pages more, that also will fall in the 103 range, and we will be able to give 34 also to S1. And if we try to give 67, it will be more than 103. So 12 plus 34 plus 67 will be 113, and it will be more than 103. So we won't be able to give this book to student 1. So in that case, we should give that to student 2, and if we try to give 90 to student 2, that also will fall outside this range. So that means our minimum, we should increase the minimum value. All the books that are less than 103 won't be able to like if we provide the maximum value as maximum number of pages as 103 for a particular student, we won't be able to distribute it between 2 students. So in that case, we should increase our minimum value, and our minimum value will become 104 in this case, and our maximum value will be 116, and mid will be calculated as 110. So again, if we try to distribute it between 2 students for S1, we can give 12, then 34 is possible, and if we try to give 67, it is not possible since it is greater than 110. And now we give for student 2 we will be giving 67, and if we try to give 90 also, it will be greater than 110, and we won't be able to split it between two students. So again we meet the condition where we should increase our low value since we are not able to distribute with 110 pages. So we should increase the number since we to a valid number where we can distribute between two students. So again we calculate the mid, and so here in our case the minimum value will be 111, max value will be 116, and our mid will be 113. So for this case, if we check for student S1, we can give 12 book with 12 pages can be allocated to student S1. 34 can also be allocated since it is less than 113. And if we try to give 67, there we are able to allocate since our number of pages we have taken over here is 113. So if we take the sum over here, it will be 113, and it will be less than or equal to the mid value that we have taken. So that means we can allocate these 3 books to student 1, and for student 2 we can allocate book with 90 pages. So this means that with page as 113 we are able to distribute between two students S1 and S2. Now our objective is to find the smallest possible maximum. That means we need to check whether there is any other possibilities which can be which will be less than 113. Since 113 is possible, all the pages which is greater than 113 will be able to distribute between two students, and again we will keep the min as 111, sorry, and our max val will be 113 minus 1, that is 112. Again if we calculate our mid, it will be 111. Now if we try to distribute this for student S1, we can allocate book with 12 pages, 34 pages, and if we try to give 67 to student S1, it will be greater than 111. So we won't be able to distribute that to student S1. So we should go to student S2, and for student S2 we will be giving 67 pages, and if we try to give 90, then we won't be able to provide a book with 90 pages since it will be greater than 111. So we have found our solution as 113. So since we won't be able to distribute 111 to two students, then we should increase our minimum in this case. So our minimum will be 112, our max will be 112, and our mid will be 112 in that case. Now if we try to distribute, we face with the same situation as before. We will be able to provide 12 and 34 to student 1, but 67 can be allocated since it will be greater than 112. And for student S2 we can give 67, but if we try to allocate 90 to student S2, in that case also we won't be able to provide that book to student S2 since that value will be greater than 112. So our again our minimum is not a solution, and we should look for more pages in that case. So in that case we will increase the minimum value again, and it will be 113, and max will be 112. So here we have crossed the check for binary search, and we won't be able to proceed further. So while considering all these cases, we were able to split the book with the number of pages as 113, and we will store that answer and we will consider this is the smallest possible maximum that can be used to split the books. Now coming to the solution. So here there is a constraint saying each student receive at least one book. That means if the if the number of students is greater than the number of books, then we won't be able to reach a solution over there. So that is our first check over here. We will check if the array dot length is less than the number of students. So in that case we will return -1. Okay, now we will find the number of pages. So we will return find number of smallest possible maximum. So to this function we will pass our array and the number of students. Now for this function it will be returning integer, and we have two parameters over there. We have array and the number of students over here. Then we will be doing binary search. So initially we will be setting the low as 0 and our high as also 0. Then we will be iterating over the array. And here we will to high we will be storing the maximum number of pages, that is the sum of the array. And to low we will be storing the book with the maximum number of pages. So we will be checking if number is greater than low, that means we should update the low as number. So after this iteration we will have the low and high value for our binary search, and we will be setting the answer as -1, and we will be doing the binary search operation. So while low less than or equal to high, we will be calculating mid plus high by 2. Now we will be calculating the number of students. So we will create a function find number of students. So in here we will be passing the array and the number of pages, so that we can find to how many students that we can distribute the given number of pages. So if the number of students is less than or equal to k, that means this means that we can distribute mid number of pages to k students. So that means all the pages which are greater than mid can also be distributed. So we need to bring down the number of pages. So our answer can be mid, and our high will get reduced to mid -1. And in the else case, if it is not possible to distribute for k students, that means we should increase the number of pages that we have taken. So our low should be greater than mid +1. Now once this is done, we can return answer from here. Now to find the number of students, public int number of students, and we will be passing int array and also the number of pages, int pages. Now we can initially take the number of student as 1 and the number of pages as 0. Now we can iterate over the array we can count the number of pages which can be distributed for the student. So we will be counting array of I. Now we got the number of pages, and we check whether our pages falls under the number of books that we have allocated for this particular student. So we'll be checking if number of pages allocated for student is greater than pages, we won't be able to allocate to the same student. So in that case, we will increase the student count as by 1, and also the number of pages will reinitialize to the array of I. Now once this is done, we can return the student count, and if we try and run the solution, we get the expected result. Now if we look at the time complexity, this is n log n, and if we try to submit it, it will pass all the test cases. So our time complexity will be big of n log n. So here we are taking log n time, and we will be iterating over the array n times. So it will be n log n, and we are not using an extra space, and our space complexity will be big of 1.